Hi, in this video I'm going to show you a solved problem, and this is on finding the zeros of rational functions. Now before I show you the solution to this problem, actually I have two examples to show you the main ideas in finding the zeros of rational functions. Let me first define what are zeros of rational functions. So the zeros of rational functions are the numbers, these are the x values that will make the function, well, that is our f of x, equal to 0. So in short, we are looking for x where f of x will become equal to 0. And that's basically the main idea in finding the zero of a rational function. All we have to do is to set the function to 0. So let me use two very similar examples, but will require important attention to the possible numbers that we can accept. Okay, now by the way, just to extend the idea of these x values that will make the function f of x equal to 0, it means when you substitute that number to every x and you simplify the expression, it will become 0. If that will happen, then x, or that x value, is a zero of a rational function. But of course we do not like to do trial and error, like trying to put some numbers and hoping that it will become 0. That can solve the problem, but it's not the most efficient way of finding the zeros of the function. So let us do the first example. So I have here f of x is equal to x squared minus 5x plus 6 over x squared minus 8x minus 9. So by the idea, we set this expression, so we will write that now. We have to make our f of x equal to 0. So if this is 0, that means x squared minus 5x plus 6 over x squared minus 8x minus 9 is equal to 0. Or if we will just arrange how the equation is written, so you have 8x minus 9 here, so equal to 0. So they're basically the same. I'm just putting the right side now to the left side and 0 to the other side. Now once you have set it to 0, this is what you need to do. Okay, do not go ahead and cross multiply. Some people will tell you immediately cross multiply the denominator. Do not do that, okay, because you might miss, or you might include x that are not actually zeros of the function. So my way is, before you multiply, you cross multiply or simplify the equation, what I suggest is to factor the given expressions. And since we are involved with quadratic expressions in the rational function, so when you factor these expressions, you get two binomial factors. At this point, if you're not confident with your factoring techniques, you need to review that, because you will use that a lot in finding the zeros of rational functions. So x squared minus 5x plus 6. So you should know that the factors are, so x minus 3 and x minus 2. Minus 3 and minus 2 to get positive 6. Minus 3 and minus 2 to get negative 5. In the denominator, x squared minus 8x minus 9. That's an x and x for x squared. I can have 9 and 1, negative 9 and plus 1. Negative 9 times 1 is negative 9. Negative 9 plus 1 is negative 8. So keep in mind, this is still set to 0. Now, once you have factored the expressions, try to check if you can cancel any of the factors. That's why I do not suggest to cross multiply immediately, because there might be some expressions that can be cancelled. However, in this case, you have x minus 3, x minus 2, x minus 9, x plus 1. They're all different. So you are safe now to multiply both sides by the denominator, or simply cross multiply. Well, I don't use the term cross multiplication in my solutions, because that is not a formal well, that's not um, formally expressed or like say in a procedure, but what is really happening is we are multiplying both sides by x minus 9 and x plus 1, which is equivalent to the cross multiplication that we know. Okay, so when you multiply both sides by x minus 9 and x plus 1, then automatically the denominator will be cancelled with the multiplier x minus 9 and x plus 1, leaving the left side as x minus 3 and x minus 2 equal to, now 0 times anything will become 0. Okay, and then from here, when you have two factors equal to 0, it means either the first factor is 0 or the second factor is also 0. Solving these equations, we have x equals 3, that's plus 3 on both sides, and x minus 2 is x equals 2. These numbers that we have, these x values that we have, are the zeros of the function. Okay, so to give you the steps again, set the expression to 0, that's your number 1, and then factor the expressions, that's your number 2, and number 3, multiply by the denominator, or you can think of it as cross multiply the denominator to 0, leading you to this. And then from here, you equate each factor. So there's one factor here, another factor there, x minus 3 equal to 0, x minus 2 equal to 0, and these numbers are the zeros of the function. X equals 3 and x equals 2. And you can do an optional check. What is the optional check? You substitute 3 to every x. It will lead you to the value equal to 0. You substitute 2 to every x this time. It will lead you to the expression to become equal to 0. Okay, now I have one example here which is very similar in terms of the expression. They have the same, so the second one has the same numerator, x squared minus 5x plus 6, but the denominator is x squared minus 8x plus 12. And I will show you what I was trying to emphasize in the first example. So we follow the same idea. We have to set our f of x equal to 0. That will make x squared minus 5x plus 6 divided by x squared minus 8x plus 12 equal to 0. Factor the expressions. We already know that for x squared minus 5x plus 6, that is x minus 3 and x minus 2. In the denominator is x minus 6 and x minus 2. So again, if you need to review your factoring, you review because you will need that a lot in finding the zeros of rational function. Now look at this. Earlier in the first example, we didn't find any expressions that can be cancelled. But now we have an x minus 2 and x minus 2. Okay, so you need to cancel those expressions, and that means the x minus 2 is now eliminated to give a possible 0 of the function. So we are left with x minus 3 over x minus 6 equal to 0. So when you simplify this, multiplying both sides by x minus 6, x minus 6 here, x minus 6 there, or just as we know it's cross multiplying x minus 6 to 0 will lead to 0, so x is equal to 3. So here we only have a single 0 for the rational function. If we did not consider factoring the expressions first, we might have included x minus 2 that will lead to x equals 2 as a 0 of the rational function. However, it is not included because there is also another expression x minus 2 down below. Okay, now to relate this, why can't we accept x equals 2? Okay, this is a rational function. This is finding zeros of rational function. But do not forget that for rational expressions, x minus 3, x minus 2, x minus 6, and x minus 2, there is what we call a domain. Domain is the numbers that are applicable in the given function. And the domain of this, if you remember how to find the domain, it is dependent on the denominator. We cannot accept x that are or that will make the denominator equal to 0. And clearly, those are 6 and 2. So x cannot be 6 and x cannot be 2. Okay? So zeros are part of the domain. So since 6 and 2 are no longer in the domain, so if we did not consider x minus 2 here, if we did cancel it, and we concluded that x equals 2 is a 0, then it is in conflict with the domain. Because in the first place, x cannot be equal to 2. Which means x can also not be a 0, okay, of the rational function. Because the zeros are part of the domain. And again, just to extend more the idea, because your teacher might ask, when we speak of zeros of a given function, rational, linear, quadratic, cubic, and other functions, the zeros of a function are those x values where the graph will cross the x-axis. So you have like this one, okay? So you have these points where you cross the x-axis. So these are the zeros of the given function. So if we have some exemption in the domain, for example, in the case of x equals 2, those are asymptotes. And we cannot cross the asymptote, so we cannot have an intercept in the x-axis on that asymptote. Okay? And as you can see now, another extension of the zeros of a function. The zeros of a functions are also your x-intercepts. These are the x-intercepts of a given function. So there are many interrelated ideas. Okay, but since our goal here is to find the zeros of a function, okay, so keep in mind the process that I have discussed in this example. So first, set the function to 0, factor it, find the expressions that can be cancelled, and then multiply both sides by the remaining expression and solve the remaining equation. Okay, so I hope that was able to help you understand finding the zeros of rational functions.